essentially what we're doing is there's kind of two ways to write exponentials and logs. So exponentials by themselves, remember there's like a whole heap of exponential laws. It generally looks like a kind of exponential growth. So it looks like a function like this, and you can kind of manipulate it however you want. And its growth, and there's an asymptote. So the key features of an exponential is it has an asymptote, it has growth, it can be flipped, so it's a like a increasing function in its base form, and then we can kind of flip it and change it depending on what we want. So in all, that's kind of the type of thing it looks like. And remember, there is that asymptote right there. So for logs, it's the inverse function of what an exponential is. And what we actually do is, so if this was the exponential function, what we do is this is now the result, this is the base, and this is the power. So the bases are kept the same, but essentially the only thing that changes positions is the power and the kind of the result. So how I like to think of a log is logs are actually powers. So logs are powers, and like if we put that log up there, it would cancel out with that because we had log 2 to that, and then we would kind of cancel out and we just get 8 overall. So a log is a power, and an exponential is kind of the opposite of what happens. So like they're exact opposites of what they're trying to do, and that's why they work well together as well. So another way to phrase what a log is what powers do I need to raise the base to in order to get what's inside? So like I said, they are powers. Log base e's are very helpful, and they can be written as natural log, like ln, which is basically natural log because it's called the natural number. So and then you have also log ex as well, which is just the conventional form of writing it. Okay, so let's talk about how to simplify these logarithmic expressions. So there is a lot of logarithmic expressions that can be simplified and can be chatted about. So we'll kind of go through the log laws on the next slide. But maybe let's just give it a try together on how we simplify these. So the first thing that we're going to be looking at here is when we're trying to simplify a log, the easiest thing to do is look at the base and manipulate it as much as possible to get it as close to the base as possible. So we know 16 is just 2 to the power 4, so we can rewrite this as 2 to the power 4. And then the log law, which is relevant here, is that a log AB, oh sorry, let's not use 2 A's, a log BC is going to be equivalent to log BC to the power of A. So what we do is we kind of bring the power out to the front. So if we look here, what we can do is therefore have 4 log 2, and log 2 of 2. So what power do I need to raise 2 to get to 2 is just 1. So we essentially just get 4 here, right? Alrighty, so if we do the same thing here, so log 9, 3, we'll have log 9, and we'll have 9 to the power of, so what do we need to do to 9 to get to 3? We need to take it to the power of a half. So that's going to be equivalent to a half log 9, which is equivalent just to 1/2. Now this one is straightforward enough. What power do we need to raise 10 to get to 10? That's just going to be 1. And then if we look at this, log 2, negative 8. Now, we think to ourselves, okay, how does that work? Because what power do I need to raise 2 to get to negative 8? Is there any point where I can raise 2 if we consider the exponential form of it and we have 2 here? So that's going to be when it's equal just to 1, and that's going to be when it's equivalent. So that's 1, it's 2. So what point do we actually need? Like, we can see that it's never going to get to negative 8, right? Because it never gets to a negative number. So the last one is not possible for us. So it's really important that we remember that negative numbers cannot be included unless it's negative x, and then you flip where the graph sits. Okay, so